video, we are going to learn ratio and graph of trigonometric function. This is the last part, which is part 5. So, learning standard for this video, investigate and make generalization about the effect of the changes in constant a, b, and c on the graph of trigonometric function y equals to a sine bx plus c, y equals to a cos bx plus c, y equals to a tangent bx plus c for a greater than 0, b greater than 0. So what are the effects of changes in constant a, b, and c on the graph of trigonometric function? The diagram below shows the characteristic of a periodic function, namely period and amplitude. So period is the interval of one complete circle. As you can see, this is the period, which is one complete circle. The trigonometric function is a periodic function. The graph of a trigonometric function repeats itself on a specific interval. For example, the graph of sine function repeats itself on an interval of 360. We can say that the function y equals to sine x is a periodic function with a period of 360. Amplitude is the maximum distance measured from the center line. So this is center line, and this is the value of amplitude. It is given that the trigonometric function y equals to a sine bx plus c, y equals to a cos bx plus c, and y equals to a tangent bx plus c. So what will happen to the shape and position of the graph of the trigonometric function if the values of constant a, b, and c change? So have a look at this table. In general, this is for graph sine, cosine, and tangent. The value of a changes. What happened? So maximum and minimum value also change. Amplitude of function equals to a. So for sine and cos graph, the amplitude of the function equals to the value of a. For graph tangent, graph curvature changes. As you know, graph tangent has no amplitude. What happens if the value of b change? So the period of the function changes. The value of a just now for amplitude. The value of b for period. Period for one complete circle. When the value of b increase, the graph appears compressed horizontally. The period of the function decrease. The period of sine and cosine function equals to 360 over b, and for tangent function equals to 180 over b. What happens if the value of c change? So the position of the graph also change. When c greater than 0, the graph moves c unit vertically up the y-axis. When c less than 0, the graph moves c unit vertically down the axis. Okay, have a look at this example. The diagram on the right shows a graph of a function for y equals to sine x for x between 0 to 360 degrees. Sketch each of the following trigonometric function on the same axis. So as you can see in this diagram, this is the graph for y equals to sine x. So what happens if the function, we add the value of a, b, c, or a combination of a and b? So what happened to the graph? So have a look at this. When we add the value of amplitude in the function, then the amplitude becomes 2. As you can see, the new graph is the blue color graph. The amplitude now 2. The rest remain unchanged, only the amplitude. For graph B, this is the value for B. So as I mentioned earlier, the value of B for sine and cos tangent equals to 360 divided by B. So this is for one complete circle. So 360 divided by 2, the value of B is 2, equals to 180. Mean at 180, there is a one complete circle. So when we add B here, the value of B in the function, so the graph will compress horizontally. So now the one complete circle at 180 degree. So what happened if we add the value of C here? So just now I said the value of C is positive value. So the graph will move 1 unit up to the x-axis. So as you can see here, the graph is shift 1 unit to the upward. For D, the amplitude is changed and also the complete circle. So as you can see here, the amplitude become 2 because of the value of A here, and the the period become 180. For one complete circle, 180 degree. Have a look at example 10. Sketch each of the following trigonometric function for x greater than 0, less than 360. So this is for cos x. The amplitude is 2 and the graph will shift 1 unit upward the x-axis. So this is actually the value of C. So the amplitude, as you can see here, the graph shift 1 unit, move up 1 unit. So the amplitude is actually 2. Because of this shift, so it become 3 here. Actually the amplitude is 2. So this is the answer for A. For B, tangent 0.5. So this is the value of B. And this is the value of C. The value of C is less than 0. Mean it shift 1 unit or move 1 unit down. So the graph move 1 unit down. And the period, the value of B for period for tangent function is 180 over B. So 180 over 0.5 equals to 360. So it needs 360 degree to make a complete circle. So this is your homework, self-practice 6.2b. Okay, this is the last learning standard for this chapter. Solve problem involving graph of sine, cosine and tangent function. Have a look at this example 11. The graph shows a complete respiratory circle. The circle consists of the process of inhalation and exhalation. It occurs every 5 seconds. So for one complete circle occur 5 seconds. Airflow velocity is positive when we inhale and negative when we exhale. This velocity is measured in liter per second. If y represents the velocity of airflow after x seconds, state a function in the form of y equals to a sine bx plus c, which models the airflow in normal respiratory circle shown as the graph above. So we need to identify the value of a, b, and c. The value of a is the value of amplitude. As you can see, this is the amplitude. The value of amplitude is 0.6. The value of b is the period for one complete circle. So since this is sine graph, so the value of b is 360 over b equals to 5 seconds. So you need to calculate the value of b here. So this is the solution. The amplitude, the value of a is 0.6. The value of b is 72, which is 360 divided by 5. So as you can see, there is no movement for the graph. Therefore, the value of c is 0. So, hence, a function that models the airflow in normal respiratory circle shown as the graph is y equals to 0.6 sine 72x. Question B. What is the velocity of airflow in liter per second when the time is 7 units? So, in this function, when x equals to 7, then substitute the value of x in the function with 7. Then you will get y equals to 0.35. Hence, the airflow velocity is 0.35 liter per second when the time is 7 seconds. So that's all. This is your homework, self-practice 6.2c, and I also want you to complete extensive practice. So that's all for this video. Thank you.